Good morning, everyone. Let's derive dot product with vector. So let's begin. If our given vectors are vector a with component vectors ax in the direction of I plus ay in the direction of unit vector j plus az in the direction of unit vector k, and if another vector is b, vector b, bx in the direction of unit vector I plus by in the direction of unit vector j plus bz in the direction of unit vector k. If these are two given vectors, to find the dot product of two vectors, we can use easily this formula. A vector a dot vector b equal with magnitude of vector a magnitude of vector b cos theta. Theta is an angle between a and b. If theta is not given, so we have to use another formula. That formula is equal with this, and ax ay ax bx plus ay by plus az bz. We can use this formula if angle is not given. If we do have an angle between a and b, we can use this formula easily. But in this video, I will show you how this simple formula is obtained, and you don't have to memorize this one. After this video, you can easily derive and do any scalar product of two vectors. So let's begin. So here we have component vectors. Let's write them here. So a dot b equal with write this one here, ax in the direction of I plus ay in the direction of unit vector j plus az in the direction of unit vector k. So this is the first vector, vector a, x component, y component, and z component, dot we do have the second one, b, bx in the direction of unit vector I, by in the direction of j plus bz in the direction of unit vector k. So a dot b equal with component of a in x, y, z times dot component of b in x, y, and z. Sorry. So let's multiply them. Ax in the direction of I dot bx in the direction of I plus by in the direction of j plus bz in the direction of k, plus here we have plus, so ay in the direction of j dot bx in the direction of I, by in the direction of j plus bz in the direction of k. Here we have plus az in the direction of k, unit vector k, dot this one bx in the direction of I. I think this is visible and you are following me. By in the direction of j, unit vector j, plus bz in the direction of unit vector k. So this one is and this one and these are equal, both of them. So let's simplify it. So ax bx I unit vector I dot unit vector I plus ax by I dot j plus ax bz I dot k plus ay bx j dot I plus, here we have plus ay by j dot j plus, here we have plus ay, sorry, here is bx ay bx, yeah, ay bx j dot I. Here is I, sorry. Here is unit vector I, ay, by, j dot j. Here we have plus ay, bz, j dot k. Here we have plus az, bx, k dot I plus az, by, k dot j. Here we have j, we have k, plus az, bz, k dot k. So as we know, we have three unit vectors I, j and k. The magnitude of any unit vector is 1, and angle between them is angle between I and j is 90 degree. Angle between j and k is 90 degree also. So unit vector between angle between the three unit vector is 90 degree, and angle between I and I is 0 degree. Angle there are parallel, or unit vectors are perpendicular to each other, and I and I are parallel. That means unit vector angle between them is 0, and I, j, k, three of them are perpendicular, and angle between them is 90 degrees. So cos 0 degrees 1, as we know. Cos 90 degrees 0. Here we have reference from trigonometry. So now we can simplify by assuming this trigonometric equation. So let's simplify this one. Let's begin here. So ax, bx, I dot I. So I dot I equals to magnitude of I cos theta. Angle between two parallel vectors I and I are parallel, so magnitude of angle between parallel vector is 0, so magnitude of I is since it's unit vector 1 times 1 cos 0 degree. So 1 cos 0 degree. 1 times 1 equals 1. So I times I is 1 equals 1. J times j is 1, it's similar, and k times k is 1. Since j and k is are perpendicular, so the angle between them is 90 degrees. So cos 90 degrees 0. 0 divided by n number is 0. Here is we have 0. Here we have 0. Here we have 0. I times j 0. Here we have 0. Here we have 0. Here we have 0. Here we have 0. So finally we end up with ax, bx plus ay, by plus az, dz. So this one is equal with a dot b. So we got our first formula. So you by understanding this one, easily you can do any any scalar product of two vector without memorizing this formula. So just try to understand this derivation. So thank you for watching. I will do derivation of cross product of two vector in next one. Thank you very much.